In this lesson, we're going to talk about different types of expressions. There are two different types of expressions that we're going to talk about. One is called an algebraic expression, and the other is called a verbal expression. Now, before we talk about these two, we need to know two very important vocabulary terms that you'll see up at the top in red. The first is variable. A variable is a letter representing a number. So you can use any letter that you like. The most common letters that are used are X and N and sometimes A, B, and C. But truly you can use any letter that you'd like to represent a variable. The other word is operation, and we've been learning the operations, addition, subtraction, multiplication, and division since early years of elementary school. So those should be pretty familiar to you. So now let's talk about the algebraic expression. It's an expression with variables and operations. So it includes letters, and then it has some type of operation, and it can even have more than one operation. So I have some examples here, and you can see that all of these represent algebraic expressions. So they have variables and they have operations. And they also include numbers. Some of those numbers are coefficients and some are constants. We'll talk about that terminology a little bit later. But you can see that they're just basic expressions. Just as a reminder, an expression is basically an equation without the equal sign. So if you don't see an equal sign, you have an expression. All right, now let's talk about a verbal expression. You can see here that it's an expression with variables and operations represented in words. So basically what I'm doing is I'm taking those algebraic expressions and I'm saying them in words. I have two examples here below that you can look at, and what we're going to be doing today is taking those verbal expressions and we're going to be turning them into their appropriate algebraic expression and vice versa. So let's go ahead and on the next slide here, we are going to fill this in class, but what we're going to do is we're going to come up with as many different words that represent all of these operations: addition, subtraction, multiplication, division. And then we're going to talk about some turnaround words. Now, just to save you some time in this video, if you flip back in your notes a couple of pages, you'll notice that I put this really great cheat sheet right in your notes. And these are just translating keywords and phrases into algebraic expression tips for you. And you can see in this second column here, I have a lot of different words that are most commonly used to translate these words from algebraic to verbal or verbal to algebraic. So you can see that everything is broken down by the operations. So here I have some words for addition, such as plus or more than, the sum of, the total of, increased by, and added to. You've probably heard these before. So when you hear those words, they mean to add. And then if I scroll down here, some subtraction words. These should look familiar as well. Minus, less than, the difference of, less, decreased by, subtracted from. Another one that's not on here is fewer. Those are common subtraction words. Multiplication, times, the product of, twice, double, multiplied by, and oftentimes just the word of. A lot of times it can mean multiplication. So you have to be very careful and very aware of your translating when that word comes up. And then our division, the quotient, that's a pretty common one, divided by, and sometimes you'll even come across something like the ratio of. So anytime you see those words, they mean those operations whenever you translate them. I also have some additional items here that you can take a look at, such as powers and equations, but we're just going to focus on expressions today. So I really just wanted you to take a look at those operations. Feel free to flip back to these as you go through the video here today. All right, let's go back down, and I know back up here we didn't talk about the turnaround words. We're going to talk about the turnaround words in just a little bit. So let's just go ahead and continue it. I'm going to teach you how to translate. Now, this is one of those skills that once you have it, you have it for life. But sometimes it does take a little bit of work just to figure out what it's saying. This is very abstract, so if it takes a little bit of time to really understand this concept, it's completely understandable. So I'm going to teach you a little trick, just in case you ever run into a tricky one that you might not know right off of the top of your head. I'm going to teach you this thing called annotating. And you can annotate any verbal expression and turn it into an algebraic expression. So let's look at the first one. It says 4 increased by a number. Watch how I'm going to annotate this. Every single word, I'm going to write what it actually translates to right above it. So I'm going to write the number 4 right up top of the 4. Increased by, that means plus. And then a number is going to be, well, we don't know what a number is, so it's just going to be a variable. So I'm going to use the variable x. So if I were to translate 4 increased by a number, it's just going to translate into 4 with a plus sign and then x, and I'm done. Now, of course, that was a simple one, but we're going to definitely get into more complex ones as we continue forward. So 12 less a number. Let's go ahead and annotate it. 12 less means subtraction, and then a number, x. So 12 less a number is just going to be 12 with a subtraction sign, x. The quotient of a number and 8. So the quotient we know is division. So you can either use the little division sign like this. Sometimes you can even use the little slash because we know that we use the fraction bar for division now. So either one that you'd like to use, feel free. So the quotient of a number, which is going to be our variable x, and 8. All right, so the quotient of a number and 8, well, that's going to be x over 8. Now I'm going to give you a little tip here. Anytime that you have the word quotient and you're using the operation of division, you're going to have some kind of sequence of and. And I'll tell you right now that the and is going to tell you where the fraction bar is located. So you can see it says the quotient of a number. That's going to be the top portion or the numerator of my expression. And is going to indicate that we're going to put the fraction bar. And then we're going to put our 8 in our denominator. We're going to review that a little bit closer with two really tricky problems on the next slide. All right, let's keep going. 12 minus double a number. Let's go ahead and annotate. 12 minus, now double. Doesn't double mean times 2? Yeah, double means you're multiplying something by 2. So all I'm going to do is I'm going to write times 2 there. And then a number, x. So 12 minus double a number is just going to be 12 minus 2x. And we're good to go. All right, let's look at the last one we have here. The difference between a number and 9. So the difference between a number and 9, difference is going to be subtraction. And sometimes you'll see the word difference with the word between. Difference between, they kind of just go together. So difference between is subtraction. And that's going to be, then the next is going to be a number, x, and 9. So there we go. So the difference between a number and 9. So whatever comes first, I'm looking at the x, the variable, minus 9. I always want to keep every term in the proper sequence. A number came before 9. So I'm looking for the difference between that number and then the 9. Alrighty, so those are the very basic translating problems, and I really tried to use all of our operations to kind of show you what it looks like when you're annotating. Now we're going to get into a little bit more complex problems, and I'm going to show you a couple tips on what to do. Alright, in this next one, it's we kind of already talked about this one, but we're going to talk about it again, and it's words that use the format of blank and blank. So again, we're using that quotient. So these really show up whenever you're using division. So let me show you these two examples so you can see the difference between the two. The first one says the quotient of a number and 3 minus 5. And let's just real quick go to the second one. The quotient of a number minus 5 and 3. These can be a little tricky because they seem a lot alike. So let's just look at the first one and kind of break it down. The first one, the quotients. I'm going to go ahead and I'm going to use my division symbol. So the quotient of a number, that's x, and 3 minus 5. Now, you can see what I left out here. I left out those two words, and we talked about this earlier, of and and. I'm just going to go ahead and I'm going to put a little box around them just because I can see that this is going to help me translate the problem. So, the quotient of a number and 3. If you remember from the last time, we talked about that and is going to tell you where the division symbol is going to go. So this is going to look like this. The quotient of a number and 3. Remember, and is going to tell you where that fraction bar goes. So I'm going to say and 3. Now, that's it. It's the quotient of a number and 3. Now I want to subtract 5. So I'm going to say minus 5. It's kind of an afterthought for this one. Now, I know that's kind of tricky, but let me show you the next example and you'll be able to see it kind of put together. So let's go ahead and translate this one. The quotient of a number minus 5 and 3. I have my of and, so I'm going to go ahead and put a box around those. And let's go ahead and translate. The quotient of a number minus 5. So a number minus 5 and fraction bar 3. See the difference between the two? It's kind of tricky, but once you get the hang of it, it's a piece of cake. All right, now let's talk about another, these are little tips I have for you with translating. These are really with the harder ones. The next ones are with the words that imply grouping. So grouping meaning parentheses or really we're just going to be basically working with parentheses. But remember, grouping can mean absolute value. It can mean brackets. It can mean braces. It can mean all of those. But for right now, we're just going to focus on parentheses. So in the example, it says 2 times the sum of a number and 5. So words that imply grouping are going to look like this. Let's go ahead and annotate it. 2 times the sum of a number and 5. There's my annotation. Now, here's what implies the grouping. Do you notice how I have 2 operations, times and sum, and they're kind of right next to each other? That can often indicate that you have some type of grouping going on. So it's saying 2 times, well, 2 times what? Well, 2 times, it's going to be whatever is in this grouping here. So it's going to look like this. 2 is going to be multiplied by the sum of a number and 5, which we would translate to x plus 5. So that kind of helps you identify those grouping symbols, just noticing those 2 operations put side by side. All right, let's see if I have any more tips for you. These are my favorite tips. Now, these ones are going to be called switcheroo words. I know that's kind of a silly way to say it, but they might be really helpful to you. So phrases that require switching the order of the terms are going to be words such as from, than, to. Now, from, than, to, you're going to switcheroo. So anytime you see those 3 words, that means you're going to switch pieces within the verbal expression. So let me show you what I mean. 3 subtracted from a number. 3 subtracted from a number. Now, let's just go ahead and annotate it real quick. 3 subtracted. I have a from in there. And what I'm going to do is I'm going to use my annotation that looks like this. This is a turnaround word. So I'm going to do a little turnaround arrow and then a number. So 3 subtracted from a number. Now, in your head, you might be thinking, well, the answer is going to be 3 minus x, right? Because normally that's how we translate it. But because of our switcheroo word, we actually have to take those 2 pieces and swap their positions. So my true answer is going to be x minus 3. And you might ask, well, what's the difference? Well, if you look at the first example here, this is actually saying that x is being subtracted from 3. 3 is not being subtracted from x. And that's the one I was looking at, this one right here. It's only in the second example, the one that I'm boxing, it's where 3 is being subtracted from that variable x. So the order of the pieces in the terms do matter. You have to be very careful with these switcheroo words. Let's try another one. 5 more than a number. So 5, we know that more or more than means plus. Than is a switcheroo word, so I'm going to go ahead and switch it a and then a number. So right now it looks like 5 plus x, but it's not because it's 5 more than that number. So we actually have to flip it around to x plus 5. And then the last one here, 6 added to a number. We can see I have that word to in there. From then to, switcheroo. So 6 added, 2 is my switch around word, and then a number. So I'm going to translate it into x plus 6. Another thing to be aware of are those switcheroo words. Alrighty, and then I have one more tip I think for you, and it's the difference between similar phrases such as greater than and is greater than. The only difference between those two phrases is that word is. And it's actually a very important word because it actually means multiple things. Today we're just talking about expressions. So this is going to mean it's an inequality. But if we're talking about equations, which we'll talk about later on, is can mean an equal sign. So you have to be very careful of what it's actually translating it into. Let's look at the first example. 6 greater than a number. So 6 greater than a number. So greater than a number. I don't see an is in there. So greater, remember, is just going to be our addition symbol. That's all. It's just going to be more than. My than, I'm going to have a little switcheroo here, and then a number. So I have x plus 6. So I have 6 is greater than that number x. But in the next one, it looks identical almost, except for that is. So 6 is greater than. This right here is going to be an inequality statement, which means the greater than symbol. And then what's it greater than? It's greater than a number. So our expression is going to be 6 is greater than x. Now this is kind of teetering into leaving the expressions portion and going into an inequality, but I did want to just show that to you in case you run into that at some point in time, especially when we start getting into inequalities. Alrighty, here are some examples now going the other direction, and feel free to pause the video and cover up the right-hand side and take your algebraic expression and then put it into your own words. So it's kind of going backwards. So you're really using the exact same skills that we were just looking at, but you're just moving in the other direction. So feel free to pause the video and cover up either side that you want and see if you can translate these expressions. All right, I have one more example for you in this section here, and this is just talking about modeling an algebraic situation or an expression. So I just want to show you how to create an expression given a situation. Sometimes these are called word problems, but I just like to look at them as situational problems. These are real life examples. So while visiting Washington, D.C., you rent a Segway to see the city. You pay $15 for each hour you ride, and you also need to rent a helmet for $5. Define a variable and write an algebraic expression that will calculate the total cost of renting a Segway. All right, in these examples, this is a great way to start Algebra 1 because we're always defining a variable. We have a variable that is an unknown, we don't know what it is, and we're trying to figure out what it is. So let's go ahead and define the variable here. We can see that we're going to pay $15 for each hour that we ride. Well, couldn't we ride our Segway for 1 hour or 2 hours, or we could even ride it all day if we wanted? So that is going to indicate that our hour is going to be our variable that's unknown because we don't know how many hours we're actually going to spend on the Segway. So I'm going to label that as H. H is going to be my variable, and it's going to indicate hours. And I usually like, whenever I have a situational expression like this, I like to give my variable the letter of what I'm talking about. So hour starts with an H, so I'm going to label it H. Just makes it easier sometimes. Now we're going to create the algebraic expression. Now I know that for every hour, it's going to cost me $15. So can I say something like 15 times my H? Yeah, because for every hour, I'm going to multiply it by 15 to figure out how much I'm going to end up paying. But if you look back up in the problem, it also says you need to rent a helmet for $5. Well, that's just a one-time cost, right? Sometimes we like to call these flat fees. Meaning you're only going to pay it once. You're not going to pay it more than once. You're not going to pay $5 per hour that you're riding the Segway. It's just a one-time cost. So I'm going to go ahead and tack that one-time cost onto the end of my expression. Now, using this expression, I can figure out if I want to spend 3 hours on the Segway, how much is it going to cost me? If I want to spend 10 hours on the Segway, how much is it going to cost me? That's the expression that will answer all of those questions for me. So let's go ahead and answer the bottom question. Using your expression, how much would it cost to ride a Segway for 6 hours? Well, what I'm going to do is I'm going to go ahead and just plug in 6 for my hours. And if I simplify that down, that's going to give me $95. $95 is going to be the cost of riding a Segway in Washington, D.C. for 6 hours, given this situation. And that's how you model an algebraic situation. All right, that is the end of our Translating Expressions video. Feel free to go back and review it and before we move on to the next section.